In this episode, we're going to build a strong beginner foundation in Linux, because Linux shows up everywhere in security work, from servers and cloud workloads to appliances and containers. Even if you never become a Linux administrator, understanding how Linux is structured and how its permission model works will help you reason about real security problems, because many breaches involve misconfigured permissions, weak ownership practices, or services running with more authority than they should. Linux can feel intimidating at first because it has its own conventions and vocabulary, but the core ideas are very learnable if you focus on structure, permissions, and ownership as a system. Once you understand that system, you can start recognizing common weaknesses like overly permissive files, unsafe service configurations, and poor credential handling. We are not going to do command-by-command demonstrations, because the goal here is conceptual mastery that helps you think clearly. By the end, you should understand how Linux organizes files and processes, how permissions and ownership actually control access, and why certain Linux patterns tend to produce security problems when people assume defaults are safe. A useful starting point is understanding what Linux is in this context, which is a family of operating systems built around a common kernel and common design principles. Linux is designed for multi-user environments, where many users and many processes can exist at the same time, each with specific permissions. That multi-user design is one reason Linux is powerful and stable, but it is also why permissions matter so much, because the operating system is constantly deciding whether a user or process is allowed to read, write, or execute something. Linux also follows a strong philosophy of representing resources as files, meaning that many system components are accessed and managed through the file system interface. For beginners, the key is to see Linux as a permission-driven environment where structure and access controls are tightly connected. If you know where things live and who is allowed to touch them, you can predict how the system will behave and where risk might emerge. This foundation is what allows you to interpret security issues later, such as why a service could read sensitive files or why an attacker could alter a configuration. Understanding Linux fundamentals is therefore not just an operating system topic, it is a security thinking topic. Linux structure is built around a single unified file system tree, which means everything appears to exist under one root starting point. This differs from some environments where storage devices appear as separate trees, because Linux integrates them into one hierarchy. For beginners, the security relevance is that predictable structure helps you know where sensitive configuration files, logs, and user data tend to live. System configuration is often stored in well-known places. Application data may have standard locations, and logs have their own typical homes. This predictability is helpful for administrators, but it is also helpful for attackers, which means you should treat sensitive directories and files as important security assets. Another structural concept is that Linux uses a mixture of system-wide locations and per-user locations, which means user accounts often have their own directories that contain personal configuration and data. That matters because a compromise of one user may expose their data and their application secrets, even if system-wide files remain protected. Linux structure also includes special virtual file system areas that represent running system state, which can influence what you can observe about processes and hardware. The key takeaway is that structure is not just organization. It is a map of where secrets, controls, and evidence tend to exist. Users and groups are fundamental to Linux permissions because Linux makes most access decisions based on identity. A user account represents a principal that can own files and run processes, and a group represents a collection of users that can share access to certain resources. This design allows administrators to manage permissions at scale by assigning users to groups rather than granting individual permissions everywhere. For beginners, the security relevance is that groups can become a source of unintended access if group membership is broad or poorly managed. A user who is placed into a powerful group may gain access to sensitive directories or the ability to interact with system components. Another important concept is that processes run under user identities as well, meaning that the permissions of a process reflect the identity it runs as. If a service runs under a privileged identity, it can access more of the system, which can be useful but risky. If a service runs under a restricted identity, it has a smaller blast radius. This is the core idea behind running services with least privilege, and Linux makes it possible through user and group design. Understanding users and groups helps you see access as a purposeful design choice rather than as an accident. Permissions in Linux are commonly described through three categories of access, and those categories matter because they are the building blocks for controlling interaction with files and directories. Read permission generally controls whether content can be viewed, write permission generally controls whether content can be changed, and execute permission generally controls whether a file can be run as a program. Directories behave slightly differently because permissions on a directory influence listing and traversal, meaning whether you can see what is inside and whether you can access items inside. For beginners, the key is not to memorize every nuance, but to understand that permissions define allowed actions, and that directories are often the real boundary for data protection. If a directory is overly permissive, sensitive files inside may be exposed even if individual files appear restricted. Another important point is that permissions apply in relation to ownership, which means the same permission bits can mean different things depending on who owns the file and what group is associated with it. This is why ownership and permissions must be understood together. In security terms, permissions are your policy, and ownership is the identity that policy is anchored to. Ownership in Linux includes both a user owner and a group owner, and this dual ownership is a major reason Linux permission design is flexible. The user owner is typically the account that created or is responsible for the file, and the group owner represents a broader set of users who may share access. For beginners, it helps to think of ownership as who has primary authority over a resource and who is allowed to share in that authority. If ownership is wrong, even correct-looking permissions can create risk. For example, a sensitive configuration file owned by an unintended user could be altered by that user, even if others cannot. A group ownership that is too broad can allow many users to read or change files that should be restricted. Ownership also matters for processes, because who runs a process determines what it can touch. If a process is running as an administrative identity, it can often read and modify system files, which is dangerous if that process is compromised. This is why services are often designed to run under dedicated service accounts with limited rights. Understanding ownership is essential for security because many attacks aim to gain the ability to write to important files, such as configuration files or scripts that run automatically, and ownership controls who can do that. One of the most important Linux security concepts is the idea of privilege, meaning how much authority a user or process has over the system. In many Linux environments, there is a super-user account with broad authority, often referred to as root. The security implication is that if an attacker gains root-level access, they can typically control the entire system, alter logs, install persistence, and access sensitive data. That makes privileged access both powerful and dangerous, and it is why least privilege is not an abstract idea in Linux, but a daily operational necessity. Beginners sometimes assume that administrators should work as root all the time because it is convenient, but convenience increases risk because it widens blast radius for mistakes and compromises. A better mindset is that privileged actions should be limited to what is necessary and performed with clear intention. Privilege also shows up in how services are configured, because services that run with elevated privileges can be high risk if they have vulnerabilities. If a service must start with elevated privileges, a secure design often limits what it can do afterward by dropping privileges or restricting file access. The core lesson is that privilege is the most valuable target in a Linux environment, and controlling it is central to security. Common weaknesses in Linux often come from misaligned permissions, where files and directories are more open than intended. Overly permissive files can allow unauthorized reading of sensitive data, such as configuration files containing credentials or keys. Overly permissive directories can allow unauthorized users to place or modify files in locations that influence system behavior. Another weakness pattern involves writable locations that are used by privileged processes, because if a low-privilege user can write to a file that a privileged process executes, that is a path to privilege escalation. Misaligned ownership can also create weaknesses by giving the wrong accounts the ability to change sensitive configuration or scripts. For beginners, the key takeaway is that permissions are not just about hiding secrets. They are about preventing unauthorized change. Integrity matters as much as confidentiality because an attacker often aims to modify how the system behaves, such as by altering startup behavior or service configuration. Many Linux compromises involve writing to the right place at the right time rather than breaking encryption. When you understand how permissions and ownership control writing and execution, you can see why certain misconfigurations are dangerous even if the system seems to run normally. Another common Linux weakness comes from service exposure and configuration assumptions. Linux systems often run background services that listen for connections, and security depends on which services are running, what they expose, and what privileges they have. If a service is unnecessary, leaving it running expands the attack surface for no benefit. If a service is necessary but poorly configured, it may allow weak authentication, broad access, or insecure defaults. Beginners sometimes assume that a default configuration is safe, but defaults are often designed for usability or compatibility rather than for strict security. Another issue is that services may log sensitive information or store secrets in readable locations, which can turn a small access gain into a larger compromise. Even though we are not doing configuration steps, the concept is important. Services should be minimized, hardened, and run with least privilege. Monitoring matters here as well, because service logs often provide the first evidence of misuse or scanning. The key is to think of Linux services as doors, and each open door should be justified and guarded. When you bring these ideas together, mastering Linux fundamentals for security means understanding Linux as a structured, identity-driven system where permissions and ownership define what is possible. The file system structure tells you where important assets and evidence tend to live. Users and groups define who can act. Permissions define what actions are allowed, and ownership anchors those permissions to specific principles. Privilege defines the blast radius of any action, and controlling privilege is one of the most important security goals in Linux environments. Common weaknesses often involve overly broad permissions, misaligned ownership, and services that run with more authority or exposure than necessary, which can allow attackers to read secrets, modify behavior, or escalate privileges. For beginners, the most important takeaway is that Linux security is not primarily about obscure tricks. It is about disciplined control of access and change through permissions, ownership, and careful service design, paired with monitoring that provides evidence when something goes wrong. If you understand these fundamentals, you will be able to reason about Linux security problems clearly, ask better questions during investigations, and recognize risky patterns before they become incidents.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.